In SAP, there are three layers to our landscape. The first is the presentation layer, which is called SAP Graphical User Interface. Then we have the application server, where all the logic, functional modules, technical modules, business process is residing, it's stored. This is a repository. This is also your brain, the application server. And the third one is the database storage layer. So in SAP, ideally, the application server takes care of everything. Memory balancing, task management, and job rotation, as we can see from here, the work process. It gets a request from the user interface, and it is then dispatched to various work processes. And these work processes are numbered, sometimes sequential, sometimes random, but every work process has a certain memory to keep on processing the logic. Simple. So there are various kinds of processes: dialog request, update, background, spool, enqueue, message, gateway. Okay. Now, dialog is basically when the user is requesting some kind of either a calculation or a report or a process. That is a dialog. Update, of course, it is basically like creating a record, master data, and storing a background. There are various background jobs, like in finance, you have recurring entries, reconciliation, GRIR entries, depreciation. Those are run in background. Spool. Now, spool is basically, again, for background. It's just like background, but spools are also used for printing. Some spool requests are for background jobs, and let me show you that. SM37. This is job status, execute. SM37 production startup. And there is another one, /n SM35. Okay, now these are your batch input jobs, and these can be processed. For example, process whether in foreground, background, or errors. Okay, you can also simulate the background mode. So functional processes, functional modules actually use these T codes to run background jobs. NQ, again, it's like you have to go through a purchase order or a sales order. For example, VF03. VF03 is billing document. (907). Enter. Okay. Over here, we have a billing document for the customer. The date is this, and this is the value. So I will go, the next step, of course, is document flow. So this is logically connected. So in queue, this actually is working in a sequence. Messages, of course, when any Now this is the document flow for the sales order. Okay. And let's see journal entry for example. Now this has been created. Okay. Now this is basically following a logical pattern, a sequence. I double click. No, it's not taking me there. If I click this, display document, now I'm actually going into a logical way of doing it. Okay, counting, for example, accounting document. Now this is the financial document with debit and credit. Okay, so that's how you create logical request. Gateways, again, gateways are basically two-way communication middleware between SAP and third-party software. Now, ABAP is basically landing in the middle. It takes care of the background jobs, spool, updates, dialogue, and it also communicates with the gateway, with third-party software, Internet Communication Manager for web-based SAP execution, internet-based SAP screens. Now, ABAP message server, again, it can be for third-party software, or there's a custom-made module working outside of SAP. So ABAP will be handling the messaging. And the other messaging, of course, is also handled by ABAP. So message server handles communication between distributed dispatches, thereby enabling scalability of several parallel application servers. Gateway reader enables communication between SAP and external systems. There is one per dispatcher. So this is a dispatcher, and there will be only one gateway which will be connecting with other softwares and external systems. Internet Communication Manager, it is the communication with the SAP system using protocols as HTTP. User context. Now, what is user context? Now, this is context over here. Context. Now, context is memory allocation to contain characteristics of a user logged on. Now, SU0. SAP was net display default. Now, these are some of the formats which are defaulted. Okay. And for example, language is English, decimal notation can be different, and it is up to the choice. Date format can be different. Okay. Time format, it can be different. Okay. So these are some by default allocation of characteristics of a user. Holds information needed by the system about user, like user current settings, authorizations, name of the program using is currently using and running. So now work process, as we saw, is what it comprises of some segments. There are request queues at dispatcher level, which are assigned to the work process. Work process is handling the tasks, and there is an interpreter where we code the logic, and it communicates with the screen processor. Now, this screen is for SAP screen, and it processes the logic over here using interpretation and database interfaces. An interface interacts using the database layer. So the user context, I've already told you. And the application layer, of course, will be having other tasks like factory calendar, screens, programs, tables to handle, and this is actually handling with multiple simultaneous instances with n number of processes. Okay. So bigger the system, bigger the work process, and many number of work processes. Database layer is a central database in which the data set is stored. It also stores the record, master record also. Software component responsible for database layer consists of RDMS and the actual database. So application data also comes with administration data, customizing settings, which is functional customizations. ABAP codes are also stored here. So in effect, now we have various tasks that will be handled through ABAP Dispatcher, and that are dialog, enqueue, spool, buffer, and so on. And this is communicating through database application layer or database interface. Buffer is basically to handle parallel processing of all the work process one by one, allocating capacities to every work process so everything runs in parallel and SAP screens are not stuck. Okay, that's how smart this system is. Buffer helps to speed up processing of request. That is, data is often read but seldom changed, like customizing currencies, company codes. So buffer stores some fixed data like company code. Now, what is a company code? No, ABAP Dispatcher is not a software developer. ABAP Dispatcher is a layer which controls and executes the logic and handles the request coming from the presentation or the screens. Okay. Now, for example, if I go to FS00, over here, LAP9, over here, we have GL accounts. GL accounts will have a representation currency or interpretation currency of INR. So any transaction going in this account will be represented in INR. So this is basically the buffer that will be storing INR for the company code LAP9. Company code is just a company name, and it's called company code in SAP. So summarizing it, this is basically how application is communicating with the database layer using database interfaces, which has a local buffer, which has customizations and default data, using gateways of native SQL and Open SQL. Now, these are the landscapes to handle databases. So it's ABAP is using Java and SQL and combinations of both to write, update, and retrieve data for the screen for the presentation layer. So ABAP programs in the client server architecture is the fundamental task of ABAP programs to process data from database in a user-driven manner. User generates a request. They receive inputs from the presentation layer and work with data in the database layer. So ABAP is fundamentally very central to processing the logic. Okay. So now, for example, SC38, no, SC11. SE11, MARA display. Now this is the table. General material data which has these fields. Some fields are key fields and some are initialized, means these fields cannot be empty or zero. It will have some initial value, like client. Now what is a client? Client is your landscape. Okay, client is your landscape 100 and it cannot be empty. Material number, yes, because this is a material data table. It has to have material number. Without that, this table is of no use. And there are many fields. Along with the number of fields, we have data types of these fields. Name of person who created the object, character. This is date of last change. Data type is DATS, which is the size of 8, fixed. Material type, okay. So these tables are fundamental to our creating the logic. Now, for example, SC38 24 this ZT 59 24 December basic program. Basic program 24th of December, executable program, save, local object. Okay, parameters PMAKT, type PMAKT, type type C. Okay. Okay. Over here, we will write equals PMAKT. Check. Activate. Direct processing. PMAKT. Okay. Data VA MAC type MAC. Now, what is MAC? Let me show you. SC11 MAKT display. Now this is a table, material description. Okay. Now we want to bring material description, so we will use material number. Okay. And it will be of character 40 length, and we want to also write description MAKTX and using Matner. Okay. TY Matner type Matner. MAKT into TY Matner, where Matner is equal to PMAT, PMatner, PMatner. Okay. Type C, size. Check. MAKT WAMACT Matner. Okay. Since we were describing the type of PMatner as C character, but Matner also has the data set and character of data set of character. Okay, so it will inherit the size 40. Okay. Check. Matner MAKTX. Where Matner equals PMatner. So select single. Now what we are doing is MAKTX unknown. Okay. MAKTX type MAKTX. Matner type Matner. Check. Okay. Now MAKT is a table. WA is work area of MAKT. So we are initializing a variable, a bucket. Now this WAMACT is nothing but a label of that bucket. Label means any nameplate of the car, of the house. This is the nameplate. And this nameplate is of a bucket which will store information of table MAKT. But how? For that, we need material number, MAKTX description. Again, MAKTX is what? MAKTX is again a label of material description. Matner, type matter is material number. Okay. So P matter, P means here is parameter. input parameter. Select single record from MAKT into work area MAKT where Matner equals pmatner. Write MAKT Matner MACTEX. Okay. Activate. Now, write means print all of this. Print whatever is in MAKT, WMAKT, Matner, and MAKTX. Direct processing. LAP9FG. Execute. So we have 100 LAP9FG and it is printing data of 3 variables, which was MAKT, Matner, MACTEX. Okay. So this is how we will create a program, and this program will be